Cool. So I'm going to talk about JWTs, and JWT stands for JSON Web Tokens, and we'll dive into a little bit of the use case for JWTs, and then at the very end, I'll cover creating a JWT in Ruby and some ways for you to consume JWTs. But mostly this talk is about what is a JWT, why might you want one, what's the use case for it. And real quick about my employer, we are a drop-in user data store. So we do stuff like OAuth, user management, SAML, login, forgot password, and it's free as in beer. It's not open source, but you can run the community edition for free. And where that's germane for today's talk is that we produce a whole lot of JWTs. That's one of our main ways for basically integrating with other systems. So you'll log in to FusionAuth using an OAuth grant or some other way, and then we'll produce a JWT that you can then present to other services and basically be authorized against other services. So I'm not going to talk about FusionAuth much more, but it's out there, and we'd love if you would kick the tires on it. So about me, who cares? Y'all didn't really come here to learn about Dan Moore. You came here to learn about JSON Web Tokens. Real quick, if you have any questions, please feel free to unmute and interrupt me. If I lag, please tell me. I do actually have the chat window up, so I'll be checking that as well. And I've done in the past, depending on your comfort level, I have found that I myself pay more attention when I'm unmuted because I can't, tab over another thing, look at something else. So if you want to unmute and ask me questions or just stay unmuted the entire time, that won't bother me. But I always prefer for a presentation to be a discussion rather than me talking at you, especially on Zoom. So if I say anything that doesn't make sense or that you think is wrong or that you want to ask for clarification on, please feel free to do so. So JWTs are a web standard. They are pronounced JWT, and it stands for JSON Web Token. And basically, it is a stateless, portable identifier for identity. So it's really great because you can have one system produce a JWT, and then you can provide it as a means of authorization for other or authentication, depending on what the contents of the JWT are. For other systems. So especially if you're building, 1, 2, 3, 4, well, not so much one, but 2, 3, 4, 5 different services, and you want to have one central authentication point that people or systems authenticate with, and then you generate this JWT, which is again a standard, and you can then have the client present that to different systems. It's produced by a lot of identity provider servers, not just FusionAuth. One thing that's worth noting is that it's base64 encoded, and we'll actually dive into kind of the mechanics of a JWT, what it looks like later, but it is not private. So JWTs are, you can verify the integrity of JWTs, and we'll talk about some of the ways to do that. You can also encrypt them, but that's not a standard thing to do. Most of the JWTs I've seen have been signed, but not encrypted. And what signed means is, like anything else, you can verify that the contents have not shifted or been changed by somebody nefarious in the middle, but anybody can read it if they get a handle of it. So let's talk about the use case. So here we are, we have a typical application. It has a couple of different APIs. There's a user API, which goes against the user's data store. We have a to-do API, which goes against a to-do data store. Let's dive into those a little bit more. The user API, pretty typical, right? This is probably one of the first tables that anyone creates anytime they're building an application. You have users, you have roles, and you have a join table between the two. So you'll basically want to be able to retrieve a user by ID or by some other identifier like email address and find out what roles they have so that you know what access they can have to various to-dos. Because someone who's an admin user is going to have greater access to than someone who's just a normal user who might have greater access than someone who's anonymous. The to-do API is much simpler. just a table of to-dos. And that table might look a little bit something like this in a more traditional monolith application. But when you're separating things out to APIs, you can't, this ID may or may not make sense as an integer. So when we are actually going about the process of, as a client, building the to-do application, right? So we want to find who this user is by them logging in and then going and getting the to-dos for that user and displaying them and possibly updating them. So the way this would work is we would have the client post to login to the user API. So that's going to be passing the username and password. The user API is going to validate who this user is by checking against the user's table or the user's data store, and then pass back the user as JSON. And then the client is going to make further use of that data. So that JSON might look a little bit something like this. You know, it has an ID, a name, an email, and then roles. Again, so that the roles can be consumed by some other part of the API or some other system and grant me appropriate access. So one way to do this would be for you to pass that user ID, 42, from the client, which extracts it from the JSON, and pass that to the to-do API, which then would look up all the to-dos for user ID 42, and then pass that back as JSON for the client to actually display. The problem with this is that there's a lot of danger there, because if I am a nefarious client, I can notice that, oh, we're passing back the user ID as an integer. I wonder what user ID 41, what their to-dos are, or user ID number 1. And so you don't want to do that. So, it's very, very important for me and my to-dos to be protected. So I don't want anyone else to know that I'm going to get milk today. So what are steps you can take to make this slightly more secure? Well, the next step to take is to use an opaque token. So when the client authenticates with the user API, again, after verifying the users who they say they are based on a password and a username typically, but it could be MFA, it could be any other solution, the user API is going to generate some opaque token. And that's going to get passed down to the client, and the client will pass that back to the to-do API. This has the benefit of the nefarious client not being able to iterate over possible IDs, because this token, could be a random string of alphanumeric characters, could be a bunch of bytes. It doesn't really matter what it is, but it's not something that can be iterated. Now, when the to-do API actually needs the ID of the user, they're going to have to, the to-do API will have to call into the user API, and some standard endpoint or agreed upon endpoint, get back that user's JSON. Now that user is never, that JSON is never seen by the client, just by the user API and the to-do API. So it's protected to some extent. This is a very valid pattern for authentication and for generating identities. The issues are that you now have the user API having to be stateful. It needs to know kind of who has logged in. It needs to be able to store that data in memory or in a database. And the biggest problem I see is that it's very chatty, right? The token, the to-do API needs to talk to the user API whenever it gets a token, unless it implements some sort of caching, right? It could implement caching over here in the to-do API. And that isn't too bad when you have 2 services. But when you have 10 or 15 or 20, suddenly everybody is, as soon as they get a token from the client, they're talking to the user API. So it enforces a lot of coupling. As we'll see, JWTs help that, but if you want to remediate some of the issues with JWTs, you're actually going to reintroduce some coupling. So a little foreshadowing for y'all. So what's the next step? Well, the next step is to use a JWT. And what a JWT does is it again, the user is going to, the client is going to authenticate with the user API. The user API will generate the JWT, and sign it. Very importantly, will sign it, pass that down to the client, and the client can then present that to Zoo API. And the Zoo API has a couple things it can do. One, it can examine the JWT, and two, it can verify who it was signed by. And both of those, along with the information you can put in a JSON Web Token, which is basically arbitrary JSON, both those mean that the Zoo API can now look things up in its own data store without talking to the user API, because it knows that JWT is valid. So there's two different ways to sign a JWT. You can sign them with a symmetric key. Well, there's three ways. You could not sign them, and we'll talk about why you should never do that. You can sign them with a symmetric key pair, which basically means you have to have a shared secret between the Zoo API and the user API, so that the Zoo API can verify who signed this and that it's a valid JWT. Or you can use public-private key pair, and we'll talk a little bit about that further on and the benefits of doing so. But the actual contents can be any, again, as I mentioned, any arbitrary JSON. So you can stuff in roles, you can stuff in identifiers. What you just need to realize, and again, I mentioned this earlier, but it's worth reiterating, is that there's no secrets in a JWT. Unless, again, I'm going to kind of set aside the encrypted JWT, which is something I haven't really seen, and I haven't seen much documentation on, but you can do. It's part of the standard. But typically, you wouldn't want to put anything in a JWT that you wouldn't want put on a postcard, because anyone, if they get access to that JWT, can read it. So here's the belle of the ball, the final, there's been a lot of build up to JWTs. So this is an actual JWT that is valid, JSON Web Token. And there are three parts to it. There's the header, and then which is in green. There's the blue part, which is the payload. And then there's I guess that'd be a kind of a pale yellow. And that is the signature. And they're all separated by full stops. So let's look at the header. The header, again, and these are just base64 encoded. So if you just Googled base64 online encoder and you pasted in this value, you would get back this string. And the header includes things like which algorithm was used to sign this, which key, if there are multiple keys that might work with it. And there are a couple other claims that you can put into the header. And a claim, by the way, is just a key here. So the alg claim is HS256 in this instance. So the header is really designed to give you kind of metadata about the JWT, and it will help any libraries or custom code that you write to validate the JWT. So basically, if you see an algorithm of HS256, you know you should actually verify this JWT signature with that algorithm. This is an example of a body. And again, this is base64 encoded. So there are three types of claims. There are standardized claims, there are public claims, I think they're called registered claims actually, and then there are private claims. So standardized claims are claims that are, as you imagine, are defined in the standard. So ISS is one of those, where it says that that is the issuer of the JWT. And that can be any kind of string, and that really what kind of string it is depends on who is building the JWT, but it needs to be something that a consumer of a JWT can say, oh, who do I expect created this JSON Web Token? It is who I expected. I can move forward. Exp is another standardized claim, and this basically says this is the time period beyond which this JWT should not be valid. So JWTs are issued with an expiration, and that means that if you are looking at a JWT as a consumer of a JWT and you don't see an expiration or your expiration is in the past, you shouldn't do anything with it because it basically means that it's expired. Odd and sub are both identifiers. Odd is who this JWT was created for. So again, that's something the consumer should check. Basically, when they can get a JWT, they should say, okay, do I know who issued it? Do I know that it's expired or it hasn't expired? And am I the person or am I the service that this JWT was created for? Otherwise, I shouldn't proceed at all. And then sub is the identifier for the subject of the JWT, which basically means it's called a principal in other areas. It's basically who this JWT is about. Name is a registered claim. And so that means that it's not standardized, but there's kind of like this pool of names for claims that are out there that you can basically lay, it's kind of like DNS, you can kind of lay claim to a name and then it has like a more standardized meaning, but it's not in the RFC. And then roles is a private claim. You can do whatever you want with roles. The nice thing about roles is it shows you that you can build more complicated data structures in a JWT. So you could have arrays or you could have other objects if you wanted. All right. And then here's the JWT signature. And this is going to be, you know, one of the commonly used algorithms, elliptical curve cryptography, RSA, symmetric signing with HMAC. You typically aren't going to care too much about the signature other than to make sure it's there and then to verify that it corresponds to the body of the JWT. So finally, the To API takes this JWT, verifies that all the claims are as expected, looks at the subject, and now can do this select star from to-dos where this user ID is the subject ID. So again, the major win for a JWT is that you don't have to call back home to the user API to verify that someone has authenticated in the past because that JWT is generated by the identity provider. So there are some things to be aware of around JWT. And actually, if you look online, there's a lot of hate around JWTs because they're kind of complicated. And you do just need to make sure you're using them correctly. So one of the big foot guns is the fact that you don't actually need to sign your JWT. So if we have this JWT, we can actually get rid of everything in red and make it look like this. So you can see we still have the header, we still have the payload, we just don't have the signature. Now, the issue with this, well, so the win is that you don't have to cryptographically sign it. And then when you're validating it, you don't have to cryptographically make sure that the signature checks. Now I put win in quotes because I don't think that there are very few situations where that makes sense. The loss is that anybody can create a JWT with a signature of none. And so if your consumer is not validating signatures, if it's accepting signature of none, then anybody who gets into your system and can kind of craft a JWT can then send any payload to your systems in terms of authorization or any of the way you use JWTs without much effort, right? So this is how it changes, you know, kind of diving down a little bit deeper. We change the algorithm to none instead of HS256. And then we basically just base64 encode the payload. So the JWT specification allows this, and, you know, this is worthy of an exclamation point. You know, we really recommend that you don't do this. I kind of already went over what's wrong with it, but the simple fix is just don't ever allow it. So if you are consuming a JWT, if you're generating JWTs, don't ever choose a none algorithm. And we actually don't allow that with FusionAuth. That's just not an option. Although you can use the other libraries to generate JWTs, and they definitely allow you to use that algorithm. And then if you're consuming a JWT and you ever see algorithm none, or you don't see a signature, you should throw up your hands and not consume the JWT. Now, I've been a consultant for a number of years, and so there's always exceptions, right? And so the reason why this is in the specification is because the specification, whoever's writing it was aware there were times when you need the flexibility to not have a signed job. And so if you have benchmarked your system and you know that the overhead of signing or verifying a signature is too high, and you have some other way to verify a JWT is unchanged, right? So that nobody bad can get in your system. An example that could be using mutual TLS. Another example could be if you had a system that was air gapped, right? That was was isolated in terms of the network level, and you just always knew every client on that network. Then you could use algorithm none. Now, I will say that I imagine anyone with those kind of specifications probably is not attending a intro to JSON Web Tokens talk at Southwest Ruby. So actually, that's an open question. Has anyone actually used algorithm none for their JWTs?
I used it in the test suite when I did a integration for Apple, like sign in with Apple, just for like stubbing the token, I guess. But I just checked the code, and I think I changed it later on to like stub it with an actual token. So I guess I kind of used it, but it was just for like testing purposes, and it's not there anymore.
That's actually that's a great example of where it may make sense, right? Because it's like, who cares if the JWT is corrupted somehow in a test, right? Or it matters a lot less in production, for sure. Was someone else talking? I thought someone else had a comment. Okay. So I have a couple of questions I see. Sorry, I got so wrapped up in my presentation. Looks like Ollie had a question, and Richard. Yeah. A signature assures that the JWT was created by the issuer, and the issuer only created the JWT for authentication. Yes, that is exactly the win of a JWT. Is it's a standardized way to do that. Now, if you are using a symmetric key, then anybody who owns that symmetric key, which you need to actually have to decrypt or to verify the signature as well as to generate the signature, anyone with that signature could conceivably create a JWT that looks like it is from the the authentication service, right? So that's one of the things that you want to think about when you're trying to decide whether you're using a symmetric algorithm like HMAC or a public-private key algorithm like RSA or elliptic curve cryptography. But so Nisant says, where do you recommend storing the private key of the public-private key pair since it has to be stored safely? Yeah, so is this in the context of a Rails application, or is this in the context of an identity provider, or just kind of general recommendation?
Both for Rails and then as a general recommendation.
Sorry, I didn't catch that. Oh, gotcha, for Rails. I would store it, sorry, thanks. I would store it any other place that I would store something secret, right? Like this is just like the secret key base. So if I was doing a Heroku application, I would store it in the environment, right? Or something like that. I don't think it's, you can rotate keys, and you probably should, depending on, there are ramifications for rotating keys, and there could be operational issues too if you have to distribute a symmetric key to multiple different services. There's going to be kind of a time when a JWT would be invalid, and so you want to think about that. But yeah, it's like any other secret. Cool, good question.
I got a quick question. At the point where you actually obtain the JWT token from the authentication server, are there any mechanisms like the OAuth Pixie flow that allow you to have like a kind of like a mobile client or something to verify that the token that you got back is from the like authorizing server. I'm not sure I explained that more. Oh.
Yeah, so the client shouldn't really care, right? Because the client, and it depends on whether you're talking about OAuth or OIDC, but in general, like the client says, and one of the people I saw a presentation, I want to give credit where credit's due. He said, like, this token, this JWT is very much like a hotel key card, right? Like you're handed a hotel key card by the person at the hotel and you don't care what's on it. So the client really shouldn't care what's on it, a mobile client. It should just store it safely. And in the case of a mobile client, we actually had someone write a sample application for us. And you want to use the shared preferences, or I'd have to go look up what it was for Apple, the keychain, but you want to store it someplace safe and secure, and then you want to present it. But you as a client don't care what it says. You just got it and you're going to like present it to other people. Again, that's OAuth more than OIDC. OIDC, you might want to like decode it. But does that answer your question?
I get that in terms of like, you've got this key and then it's only on the services that are actually like giving you the data that need to actually be the ones that are verifying it. So the client doesn't really care. It's just kind of passing it on. But what I actually meant was at the point of obtaining the key, can you prove to the authentication server who you are as a client in terms of saying, I want to consume this API, I want to like authorize as, I don't know, the NHS contract tracing app or something like that. And you should not authenticate me unless like I can prove. Now, I know that the OAuth standard like uses the Pixie flow to like say, I genuinely am this client. And I didn't know whether there was any standards around like JWT at the point of token generation that did that.
Yeah, that's a great point. That's a good question. So I would say that Pixie is the way to do that. If you have a public client like a mobile app, right, which is what you basically asked about, Pixie is the right way to do that. You could obviously do it other ways, right? You could have an API key that the authentication server knows, right? An API key that's distributed to all the different mobile clients that the authorization server knows how to decode, but that's not going to be a standards-based thing. So Pixie's the way to go for a mobile client. Yeah. Does that answer your question? I want to make sure.
I think it does. I didn't know there was any, I didn't like, I was aware of the Pixie flow. I didn't know whether there was any like sort of standard ways of getting the token with the Pixie flow with JWT. And it was quite tightly integrated into like a lot of the OAuth client libraries. So
yep,
didn't know if that was a thing or not.
Yeah, I mean, and so here's the thing, like OAuth, a lot of JWT is, certainly my experience, is like really around the OAuth standards. But you could, again, you don't have to use OAuth. You could choose to authenticate in any other way you wanted to authenticate. Again, I gave the example of API key, but it could be something else, something more complicated, and then get back a JWT. And that JWT could be handed out to other people totally independent of OAuth. But OAuth is typically how I've seen it done. So, Nisant had another question. How does it affect session invalidation? Say a user's laptop is stolen or compromised. Is it possible to invalidate a session? So if you're using your JWTs to present like, hey, this client is authorized to access the to-do API, and someone's laptop is stolen, that JWT is still valid because for the given period of time. And I'm going to skip over that question because I'm going to actually address it in later slides. And Nisant, definitely call me out. Call me out, one, if I'm mispronouncing your name, please. And then call me out if I don't actually answer your question about session validation at the end of the presentation, because I do address that, because that's definitely an issue with JWT. Okay. All right. So basically kind of previously I was talking about symmetric key signatures. And so that works really well where you control all of the servers, right? Because again, I mentioned if you want to rotate your keys or even just to not rotate them, just get them distributed the first time, you're going to have to share that secret all over the place. And if that's 2 or 3 services, that could be not a big deal. But the nice thing about using public key signatures is that it decouples the identity store and your services even more. So let's kind of walk you through this. So imagine that the user API is run by one part of your organization, the to API is run by another part, or possibly an entirely different company that you just want to allow to have access to the system, right? Or to have access to you, to know who your users are. Well, what you can do is you can sign the JWT with a private key, which again should be stored securely the same way as all your private information is stored. And then once the JWT is signed, it gets past the client. The client, again, doesn't really look at it, just treats it as an opaque token, passes it to the JWT API. The JWT API now needs to get the public key of the key pair that was that corresponds to the private key that signed the JWT to verify that the JWT was unchanged in flight. And what it actually can do is it can call into a endpoint. So the user API, whenever it generates a private key, can actually publish a public key. And this actually is the non-standard location for it. This is the FusionAuth location, but there is a standard location. I think JWTs is the standard, and that is a place where identity provider can publish a key, and the JWT API can then go grab that key and pull it down and verify that the JWT is valid. Now, you may say, Dan, this is coupling the user API and the JWT API again, which is something we were trying to avoid when we talked about why we should move from opaque tokens to JWTs. And I would say, yes, there is some level of coupling here, but it's a lot less, right? You're not making a request every time you get a token or building your own caching layer. You can, well, you may want to or need to cache the public keys, but you can do this a lot less often, right? You can pull that public key every hour or 2 hours and just store it, or you could pull it every time. So you could pull it once and then just keep using it until you see a JWT that you can't decode. And then you could go back and say, oh, this JWT doesn't look like it's valid according to key A. Let's go see if there's a new key published. So this is how what the endpoint will look like. So it's basically just, again, a public key, RSA public key. And if you have multiple keys, which you may want to have, you can actually put the key ID in the JWT header, which tells the consumer of the JWT, hey, this was signed with key ID 42. Then the consumer can go look at that endpoint and see which of the keys it corresponds to, and then use that key to validate and decode the JWT. So you may want to have separate keys for separate systems, right? Because it may make sense if you have a to-do API and an email API and whatnot, you may want to sign the JWTs for those different audiences with different keys. And again, this is just how the JSON that delivers the public keys to the consumer of the API, the consumer of the JWT would look. So JWTs are supposed to be short-lived. And I think in the specification, they specify on the order of kind of minutes or hours. Refresh tokens are a different kind of concept that can be used to create new JWTs. And so the idea is, well, actually, there's a great diagram. So basically the idea is a client sends their user to the user API and makes sure that user is authenticated. The user API then sends down a refresh token and a JSON Web Token. The client stores both those in a secure location. The JWT has an expiration, maybe of a couple of minutes, maybe of a couple hours. The client, as it is communicating with the to-do API, again, to build that to-do API or that to-do app, will present the JWT periodically. And the to-do API will look at that JWT, verify, again, the issuer, the audience, the expiration, all the things that someone should do to responsibly consume a JWT. And eventually it will expire. And then the to API will send back a 403 and say, hey, client, this JWT is no good anymore. Take it away from me. And the client can then catch that exception or catch that response, that status code, and say, okay, well, I'm going to present this refresh token to the user API. And the user API will look at the refresh token and manage it and make sure that the user hasn't logged out, that the refresh token is still valid, and any other business logic that it wants to do. And if it's all good, it will issue another JWT. And that JWT will be stored by the client and then presented again to the to-do API. So the refresh token is a way for you to maintain short-lived JSON Web Tokens, but at the same time, not require the user login every time a JWT expires. All right. So as far as deleting users, if you were in a normal monolith, a Rails monolith, you would just do a delete from users where user ID equals 42. And then you might have an on-delete cascade or some other way to make sure that all the user data was also removed, right? Because you want to make sure that you don't have any basically orphaned to-dos when the user wants to delete their data, both for kind of cleanliness of the data and then also for some regulatory reasons, depending on where your customers are. In a distributed system, you don't have on-delete cascade. So how can you deal with this? Well, you have a couple options. One is you can push the complexity to the client. The other is you can push the complexity to the server side. And I don't know about you all, but if I have a choice between those two things, I will pick pushing complexity to the server side all day and all night. But let's talk about how you do it with the client. So basically, the client just has to issue deletes to the user API and the to-do API and the email API and any other API that they may have saying, hey, this user is deleting this application or they want to delete their account. Clean yourself up. If you go with pushing complexity to the server side, what you can do is you can have your user API basically accept a list of interested APIs that want to know when a user is deleted. So in this case, the to-do API, when it first boots up or when you configure it, when it's first deployed, might be a good way to do that. You would say to the to-do API would say to the user API, hey, I'm interested in knowing about delete events. So if any user wants to be deleted, let me know, and then I will go ahead and delete all their to-dos. And this has the virtue of being less impact on the client and being a lot more scalable, right? So you can just have as many services as you want, register with the user API, and then they all get that delete event. As far as revocation, logout, which is Nisant's question, you want to typically revoke the refresh token, and that prevents new JWTs from being generated. However, when you do this, the client should delete the JWT and delete the refresh token. The user ID, the user API can delete the refresh token or mark it invalid. But the question is, as Nisant pointed out, that JWT is still floating around and it's good for another 5 minutes, another hour, kind of depends on what the configuration was when the user API generated it. What do you do about that? Well, you want to make sure, first you want to make sure that you revoke all your refresh tokens. Then you want to think about what is the risk model, and do I need to revoke this JWT when someone signs out? So the answer is that you can sort of revoke JWTs, and we'll kind of walk through a couple of different options for doing so. And I would say that you really do want to think about the risk model. In this particular application, if someone can access to-dos, if someone steals a JWT and, you know, again, and hopefully, actually, let's go back here real quick. You know, hopefully all this communication, please tell me, is over TLS, right? So someone has to do a certain amount of, they have to be bad on the client, or they have to man in the middle of you, or they have to get access to your server systems to get that JWT, right? But let's suppose that for this application, I might say, I'm going to make my JWTs kind of short-lived, 5 minutes, and I'm going to accept that there's that risk where someone could steal a JWT and have 5 minutes of access. There are other situations where you might not want to accept that risk. So if a user's account has been breached or something like that, where you know that their account is no longer secure, you may want to revoke that JWT, you know, as soon as possible. So the first thing you can do is you can rotate your keys. And so in that case, you know, if you have an HMAC key or a public-private key, you just basically invalidate the key. And that means that things are going to go bad for your system, right? I mean, or let me rephrase that. It's the entire everybody is logged out. So that could work, right? And it depends on, again, if an admin's account's been breached, maybe that's the right thing to do. But you are going to kind of force everybody to log out, because anytime a consumer of a JWT is verifying that key, but that key has been rotated, that means that JWT is no longer valid. So you push people back to going to the refresh token. And again, depending on the size and scope of your system, it may make sense. There is a different solution, and this is something that we've actually implemented worked with clients to implement. And in this case, it's kind of a time window solution. And so what we do is, when someone logs out, we revoke their refresh token and we fire off an event to any interested parties that says, hey, this refresh token was revoked. That means that the To-Do API can now cache a list of users for which their refresh token was revoked, and users, basically that means users who have logged out. So this counters the whole stateless nature of JWT, and you need to make sure that this is a trade-off that you want to actually make. But what it lets you do is, when the To-Do API gets a JWT, it doesn't just validate based on expiration, issuer, audience, all those things. It also can check this local cache and say, did this user revoke their revoke their token? So, but we don't want any token to be invalid, because it's possible that the user signed out and signed right back in and got a new token that was valid. So what we want to do is we want to look at the expiration time. Excuse me for a second. All right, so let's assume it's May 9th, 2020 at 1:12:47. Let's also assume that our JWTs are all signed for 30 minutes. So that means that a JWT created right now will expire at 1:42:47. Now let's assume that we were informed of a breach a second ago. So we were informed of a breach at 1:12:46. So that means that JWT created 1 second ago, when we were informed of the breach, will expire at 1:42:46. So if we want to invalidate all of the JWTs that happened up until the breach, basically anything that expires before 1:42:46 on May 9th is an invalid JWT. So basically what we're doing with this time window solution is, when the breach happened at 1:12, well, this was 47, but 1:12:47, or 112.46, we are dealing with this 30-minute time frame, and we are writing custom logic around this to deal with the fact that JWTs are stateless. So this is one way to deal with sessions and revoking JWTs. Nisant, does it answer your question?
Yes, it does. Thanks.
Great. So I am running a little bit long, so I'm going to kind of shorten the code up a little bit, but I did want to show you all some code. So here we are, and this is Apache licensed. So I think I posted in the presentation. I can send this presentation to y'all later if you want, but this is using the Ruby JWT library, and this is for manually creating and decoding JWTs. So if we look at build JWT HMAC and decode JWT HMAC. So we have an HMAC secret, which please don't use this. Actually, your HMAC secret should be at least 200, depending on, I believe that the standard says if it's HS 256, you want at least 256 bits of randomness. Otherwise, people can crack your HMAC code. And there's actually a kind of a cool C open source project to do so. So make your HMAC secret longer than that. Whatever way you generate secrets for Rails is usually a good way to do that. You have your payload here, and we encode the payload. And so basically this is the section below user API is kind of pretending to be the identity provider, the user API server. And then the to-do API is the thing that's actually consuming the JWT. So if we Ruby build, you can see here's a JWT that's generated, and then it can decode it. If we take this in here and go here and Ruby, so I'm just decoding the same one. Great. Whoopie-doo, but let's change the signature to a capital W, and it throws an exception. Now, I actually need to update this code because what this code doesn't do is it doesn't look at anything else other than whatever the defaults for this JWT decode method are, which I happen to know has this JWT expired. But there is a way you can look at the issuer, you can look at the audience, you can look at any of the claims in the JWT, and you should. So I actually wrote a post about that maybe I'll send to Ollie, and he can share if it suits him. So in here, you can see that I also have different algorithms. Obviously, actually, let's look at that real quick. Build JWT RSA. In here, I'm actually generating a private key, but really you're not going to do this every time you're decoding it. You're going to pull the public key from that well-known endpoint. And then there's some benchmark code, which may be fun for you to play with. Basically just looked at like what's faster, and obviously symmetric encryption and decryption is faster than public private key encryption. But again, don't let that performance driver be the main reason why you pick it. Benchmark and determine whether or not you need to make your signed JWTs available or your signed JWTs available to external systems outside of your control before you do that. All right. Any questions about the code? I guess I should ask that before I shared it. Stop sharing it. Okay. Real quick about Rails. The question is kind of what are you trying to accomplish? If you are generating your JWTs, first of all, should you be generating your JWTs? But if you are, or you just want to parse them out, then you want to use the Ruby JWT gem. It's a real well-documented, stable gem. For authorization, you can use a before filter and look at the JWT and like do that kind of examination of the claims in your application controller. If you want to roll your own, there is device integration. I haven't actually played around with that. I just took a look at knock a bit ago, and that's actually a really great way to, it handles both the generation of JWTs, but more importantly, the consumption of JWTs. So that's probably the gem. If I was building a production system and I didn't want to just kind of play around with it and understand how JWTs were consumed, I would definitely go with knock. It hasn't had a release since 2016, but there was some code activity in the last couple of months. So I think it's still alive and kicking. JWT tools. This is one of many JWT debuggers. So you can cut and paste your JWT and it will decode that, make sure it's a valid JWT, happens to be on the FusionAuth site. And then the example code that I showed you pieces of is available on GitHub as well. And that's about it. So I want to say thank you all. I really appreciate your time and attention. And I'm happy to take questions if we have any. Otherwise, definitely want to let you get on with the next presentation. So really appreciate your time.